The network will provide you very high performance. That means the delay has to be reduced. Time taken for data movement has to be faster. At the same time, how much amount of data has to move from one point to other point. The complete data has to move from one point to other point can be possible there. Complete data. Suppose what I'm sending here, I'm sending as A, B, C like this. The complete data has to move from other point also. This is my sender. This is your receiver is there. The complete data has to move from this point to here. Then the complete data will be available at the receiving point, first point. Then the time taken for this will be as low as possible. Then the failure rate will be as low as possible. Then only we can say that network will give you highest performance. Next point is that what are the different factors that may affect the network performance? Next we will move on to the different factors that may affect on network performance can be obtained here. And now here the 5 parameters are there. They may ask you 5 marks. Explain the different factors that may affect network performance. So they may ask you for 5 marks. First point is that functionality. Functionality is the first point. Second point is that the bandwidth. Fourth point is that hardware complexity. Fifth point is that the scalability. Functionality, bandwidth, latency, hardware, complexity. These are all the 5 different factors that may affect on network performance taking place. First point is that functionality means here what is the purpose of function of the networks. Functions of network. And these functions are, first point is that data routing is the first function. Routing of the particular data from one point to other point can be possible there. Then second point is that synchronization can be done. Synchronization is there. Third point is that the interrupt handling is there. Fourth point is that the request and response. Request and responses, or you can call it as the client and server communication. Client and server communication. Last point is that in the case of memory, you can call it as the coherence, like that. That is, you can call, these are all the different, or you can say, last one more point is that the communication. These are all the different functions of this particular network can be done. So now, this particular functions has to be always higher value. Then only functionality will be very high. Then only we can say network has to give you highest performance can be possible there. Your job is now, functionality will be always higher. That means this particular different task, routing of the particular data, interrupt handling, synchronization taking place, synchronization between one point other point. Second point that request and responses taking place. Either you can say I given the suppose I am using server and client environment. What happens? The client requests a particular machine. Automatically the server responds to particular messages taking place from one point to the point, and responses coming from server to your client taking place. That is, you can say that point. That is, you can call as client and server communication taking place. Second point is that memory coherence. It means the particular data has to move from memory M1 to M2 or M3 to M3 like that, M2 to M3 or M3 to M4 or M5 to M6 like that. Between that, the data has to move from one point to the other point in the memory environment itself. It is called as memory coherence taking place. Second point I can say, last point is that the communication. The communication means whatever the data, we're going to send a particular data. I'm sending as ABC from this, and this complete data has to move from one point to other point. That is, you can call it as the complete data has to move from one point to other point without loss of data taking place. Loss of data existing, even though the time taken will be less, then we can call as performance cannot be possible there. So main objective of this functional taking place is that the communication between the nodes can be obtained here, and this communication has to play between n number of machines can be obtained here. And for that purpose, whatever the task given for a particular network, and this particular task has to perform in a better way, then only we can able to say network has to give you highest performance can be possible there. So functionality will play a very important role. Then only we can call as that particular network should give you highest performance can be obtained here like this. Second point is that the bandwidth. The bandwidth can be defined as maximum data transfer rate. Maximum data transfer rate between the nodes. That is, we can call as maximum data transfer rate between the nodes. That means here, whenever you can say N1 and N2 like this, and this N1 and N2 will be obtained here, and this between N1 and N2, this is my server and client like this. And then we are providing the network is taking place, and then we are going to use the bandwidth will play a very important role, and this bandwidth responsible for data transfer rate, we can call as Mbps. How many megabits per second can be measured here? How many megabits per second can be obtained? So here you are going to obtain here megabits per second, maybe called as Mbps like this, and this Mbps value should be always higher there. Then immediately what happens? Whenever the Mbps value will be higher, immediately the speed will be higher. Whenever the speed will be higher, immediately what happens? The time taken for data movement will be reduced. At the same time, what happens? Delay also coming less. Automatically, what happens? The performance will be increases like this. So your objective is now, my objective is that delay has to be reduced as low as possible. Time taken has to be as low as possible. Immediately, the performance will be high, can be possible there. So your objective is that we must provide the maximum bandwidth between the particular nodes can be obtained here. Next point is that third point, latency. Latency can be defined as the worst case time delay for transferring unit messages from one node to another node. From one node to another node. And that this particular delay, you can say the worst case, you can call it as always we think of that the worst case time delay existing. That what is the worst case means? In the the particular better case is there, no problem. Then we must think of always the worst case scenario environment. In that worst case, how your network has to behave. That is one more important factor. The worst case scenario, the delay will be very, very less. Then only we can say network has to give you highest performance can be possible there. So your objective is now the worst case time delay between the any two nodes, transferring of unit messages. Suppose I can say I am transferring M1. Then time taken for this is we can call it as 1 second like this. Or I am transferring M2. Time taken for this is 2 seconds like this. So that is delay. So your objective is that delay should be always as low as possible. Now my objective is that make that delay value should be always as low as possible. Then only your network has to give you highest performance can be possible there. Delay value should be always as low as possible. That makes your particular network has to give you highest performance can be possible there. Next point. Whenever we can call it as networking environment, and this networking environment will be depending on some hardware components. Next point. Networking environment, whenever you can call it as networking, and networking will be is a hardware. You can see the particular networking, all these things. And this particular network comprising of this performance will be depending on what are the different components can be used in a particular network. That is, we can call it as your hardware components can be used adopted in the particular network. And this hardware component has to give you fullest performance. Then only we can say network has to give you highest performance. So you choose the hardware component in a better way. That means choosing of proper media. Next point is that we can say the media, or you can call it as the wires can be used. And then second point is that the connectors can be used. And then switches can be used. Then gateways can be used. Or you can call it as the bridges can be used. Or you can call it as the arbitrators can be used. So all these things will be called as your hardware components can be used in a particular environment. And these hardware component has to give you highest performance. These particular hardware components has to give you highest performance taking place. And these particular devices are the components. And these components has to give you highest performance. Then only your particular network has to give you highest performance. Network performance will be depending on hardware components performance. And these hardware components has to give you fullest performance. Automatically, network performance will be very high like this. So your objective is not choosing the proper hardware components for your environment, and then choosing a proper media for your applications. That means I am going to use UTP cable can be used, coaxial cable can be used, optical fiber can be used. Then you can choose which media can be used for which environment or which applications, where I can able to use optical fiber cable and where I can able to use UTP cable and where I can able to use STP cables. That one more thing is that you can able to use high quality hardware components. One more thing that the cost will be goes on high. So your objective is not the cost cannot be high. You can say at the same time, and whenever these hardware components are increases, automatically what happens? The cost will be high. And then whenever the cost will be high, automatically nobody will prefer your network can be allowed. So your objective is that not only you are using the hardware components, should not use the hardware component as your wish. You use the hardware component depending on your applications. Use your hardware component depending on the environment. Check the hardware components for your applications. I can able to use some, in some cases, I can able to use some bridges can be used. We can able to use some router can be used. We can able to use some gateways can be used. I can able to can be used for that. So depending on the applications, you adopt some hardware components, and these hardware components has to provide the fullest performance. And these hardware components cannot be used as you wish. That means if the hardware components will be large, at the same time what happens? The cost also becomes very large like this. And these hardware components will give you the fullest performance. Then only we can make that particular system has to give you highest performance can be possible there. So your objective is now whatever the hardware components can be used, and these hardware components has to provide the highest performance. Then only your network has to give you the highest performance can be possible there. If the hardware components cannot able to give you the fullest performance, automatically what happens? Then your network cannot able to give you the fullest performance cannot be possible there. So my objective is that your objective is to provide this hardware components should be at the higher value, and this then only your performance has to be increases can be possible there. Next point we can call it as scalability. Scalability can be defined as the probability of a system has to give you highest performance by adding extra component without increasing too much cost. At the same time, the performance will be high can be possible. So some more thing that. Because the first point is that adding of, you can say, network is modularly expandable. First point is that network is modularly expandable. First point. First point is that network is modularly expandable. Second point is that by adding extra hardware components. By adding extra hardware components. or extra resources, you can call it as extra resources by adding extra hardware components or by adding extra resources. Suppose I can able to add, so next automatically what happens? Your performance should be high. Second point, your performance should be high. That means I am using existing one, I am using only n number n1 and n2 and n3 like this. Node number n1, node number n2 and node number n3. Your network will providing the options. So what happens here? The cable can be done here. We are putting, suppose I am using 10 number of systems are there starting here. At this point I am using only 4 number of systems. So automatically your network cable like this only, your cabling can be done at this point here. Then we are providing the NAC card like this. Port can be given for that. Network port will be there here. So I am using port number 1, port number 2, port number 3, port number 5, 6, 7, 8, 9 and 10 like this. Here I am using only 1, 2, 3 and 4. But I am providing 10 number of ports for this. So 1, 2, 3, 4 will be, this year I can able to use this. Okay. But even though I am providing the options for 10 number of machines starting itself. Why? What happens here? Next year I want to add one more machine. What happens? Just you can take that particular machine, you can able to plug in the port. That's all. That is, you can call it as modularly expandable. You must be always think of that. Network can be done, the particular future environment taking place. Don't make that only for 4 system. You can't able to make that work, cannot be done here. So in the future announcement, at least you must providing 20 number of machines for a particular machine, for a particular lab. Immediately what happens? Suppose this year I am having 10 number of systems. So even though I can able to provide 20 number of options for that, 20 number of ports will be ready available there. Then immediately first year I can able to put 10 number of system. Next year I can able to add 5 number of system extra, no problem, because I am also providing the options for you. Again next year 5 number of system, no problem. The problem is I can say port will be ready here. So immediately you choose the media and I can able to provide the switch. All these things will be for 24 port can be used. 24 port means I can able to insert 24 number of machines can be possible there. So I can able to provide the media will be carrying 24 number of machines. Even though I am using only 4 number at this point here, at this year, I am using only 5 number of machines here. But even though I am providing up to 24 number of machines. That is, you can call it as 24 number of machines can be done. That is called as, suppose I am adding next year, I am adding extra 5. Next year extra 5. That means called as network should be modularly expandable. And then adding extra resources. That means you can say we require some ports will be required. You can say the ports will be extra will be required. Hardware networking port is there and boxes are there. That will be called as, even though I am using 4 number of system, but we are providing 24 number of boxes are there. I can say ports will be readily available there. And that particular ports, I can say readily available there. You are what you can say, just you can add the number of machines, just plug in that. Automatically what happens? That particular time taken for inserting the 5 number of machines extra will be very less. Because networking already existing there. So automatically your job is to you add the machines only. Immediately what happens? Number of machines will be added extra. That is called automatically. This year I am using 5. Next year I am using 10. Next year I am using 15. And the next year I am having 20. And the next year I am having 4. That is called as 24. Will be maximum now. So 3 or 4 years we can't able to touch about networking environment. So that will be because that labor cost and then putting the cable, all these things will be done only once. So automatically every time we can do, automatically maintenance cost will be large, labor cost will be large. So to avoid all these things, you can able to make one time. You must invest all these things and make that system should be modularly expandable can be possible there. That is you can call as network should be always should be scalable one. Okay, starting point, the cost will be high, no problem. But that cost will be maintained for next 4 to 5 years, no problem. So for that reason, starting itself, we must provide the option for the users to expand the particular networking system can be possible there. That is, you can call it as scalability. Scalability means the modularly network should be having modularly expandable. Network should having adding extra components will be required, should be allowed. At the same time, the performance has to be increased. The performance means what here? I am using 5 number of machines, performance will be less. I am using 10 number of machines automatically, the performance will be high, can be possible there. So your objective is that the particular machine should be make it as scalable one can be possible there. These are all called as different factors that affect network performance. They may ask you for 5 marks. Then you must write these parameters and then explain each particular parameter 1 or 2 lines. That will carry 5 marks. Next, we will move on to types of networks. Can be used for connecting parallel machines or connecting the number of nodes. They may ask you different types of network can be used for connecting the number of nodes or number of machines in a particular environment. So we are going to use 2 types can be used. One is called as static network. Here you can call it as dynamic network. Static network can be used. Here we can call it as dynamic network can be adapted here. Static networks, next we are going for dynamic networks can be used here. Static network can be defined as the network is static, or you can call it as fixed networks. Here the path is fixed. One thing that you must always remember that the path is fixed. Once the path is fixed, we can't able to change the path cannot be possible there. So suppose I am using node number N1, I am using node number N2. This is I can able to give line number L1 putting this. So network, suppose I want to connect N1 and N2, we must use line number N1 only. That is fixed. We can't able to change as your wish can be possible there. That is called as static networks. So once this particular network will be fixed here like this, N3. So I can give L2 like this. Suppose I am going for N4, I am going to use L3 can be used. L1, L2, L3 like this. So immediately what happens? N1 to N2, L1. So N2 to N3, L2. N2 to N4, we are going for L3 can be possible there. So we are putting link numbers will be fixed to connect the number of nodes. And this path cannot be changed from time to time. That is, you can call as that. You can call that type of network will be called as static network can be used. So for that, fixed automatically what happens? There is no switching elements will be required. No switching elements will be required to connect the number of the nodes can be taking place. Because once the path is fixed, we can't able to change the path automatically. The media is enough for putting the line from one point to the point can be fixed. We can't have the path cannot be possible there. In the case of static network can be taking place. Topology will be always fixed there. In the case of static network can be possible there. Next point is that we are going for the different types of network can be used. Okay, linear array. Then you can call it as ring can be used. We can say examples of static networks. Linear array, then ring can be used. The cordial ring can be used. Then you can call it as the barrel shifter can be used. Then we can say tree type structure can be used. Then you can say star can be used. Cordial rings, tree type structure, star type technology can be used. Then tree type, and then next point is fat tree can be used. Then iliac mesh can be used. then torus can be used. Torus can be used. It is called as best example for head network can be used, where the path cannot be changed, taking place from one time to other point. Once the nodes are linked together, and that particular links will be constant. You can't able to change your links as your wish cannot be possible there. So L1 is between N1 and N2, and L3 will be given from N2 to N4, and L2 will be given from N2 to N3 can be possible there. So for that reason, L1, L2 and L3 will providing the links will be established between N1, N2 and N3 can be possible there. Next point is that dynamic network can be defined as, so here the path is changed from time to time. So here the switching elements is very much important, and these responsible for making dynamic environment. Switching elements are very much important. Switching elements job are very much important, and these switching elements are responsible for making the dynamic environment taking place. Dynamic environment means here, suppose I am using two cross switching elements. Suppose you can say I am using two cross switching elements. 2 cross 2. That is, you can call it as 2 inputs and 2 outputs like this. That is, you can call it as we are providing the inputs I1 and I2. Then we can go O1 and O2 can be possible there. And these switching elements, suppose I want to connect I1 to O1, then I2 to O2 can be one time. We can say first time I want to join I1 to O1 and then I2 to O2. So what I can do? I will do making straight arrangement system. That is, we can call it as straight way. So first time interval, this particular elements has to join I1 to O1, then I2 to O2 can be possible there. First time, that is, you can call time interval number 1. I will make join I1 and O1, join I2 and O2 can be possible. Or you can say, if you want to make that N1, N2, N3 or N4 like this. So N1 to N3, we can make that first time interval. We will make that N1 to N3. Second time interval, we will make that N2 to N4 like this. Node number N1 to connect node number N3. Node number N2 connect node number N4. That is, we can say, we can call it as straight. We can call it as. Same, suppose this topology cannot be changed. Circuit cannot be changed. Okay, the media cannot be changed, but I will change the path from one point to the point. Second time interval, I want to join N1 to N4. Then I want to join N2 to N3. Second time interval. I will join first time interval. This is fine. This is fine. Second time interval, what happens? I want to join N1 to N4. I want to join N2 to N3. What I must do? Suppose in the earlier case, in the case of static environment, it must change and network can be changed here. But here, no, nothing will be changed. Only switching element positions has to be altered. You can see that. Switching elements has changed the position. Automatically what happens? N1 to N4, N2 to N3 can be possible. So automatically what happens? The path is changing from first time to second time can be used. That is, we can call it as. So switching elements will play a very important role in the case of dynamic network can be possible there. And they can able to use any communication pattern. Different communication pattern can be allowed in the case of dynamic environment can be possible. Should be flexible one. Okay. Should be always flexible one. But here cannot be completely static. You can fix it is there. But here we can go for should be completely flexible can be possible there. So here fixed. Here I am going for flexible can be possible there. That is, you can say fixed environment. I am going for flexibility can be possible there. So dynamic networks best example for this. So this is the main example here. So second time Suppose I want to join, third time you can say, that is you can call this crossover. Third time I will join, I want to connect N1 to N3, N1 to N4. This is you can call as third time. That is you can say N1 to N3, N1 to N4. Like this is called as upper broadcasting. This you can call as upper broadcasting. This is you can call as upper broadcasting can be used. Where I want to join N1 to N3, N1 to N4 can be possible there. One is the source, two are the receivers can be possible. Depending on the applications. You choose the particular switching position element positions depending on the input and output nodes like this. So the fourth point is that lower broadcast, 4 time. I can say, so N2 to N3, N2 to N4, like this. Like this. N2 to N3, N2 to N4 can be obtained here. You can say I'm using N2 to N3, N2 to N4 can be possible there. It is called as lower broadcast. It is called as lower broadcasting system can be used. So I am connecting N2 to N3, N2 to N4 can be possible there. I can say, so immediately what is it called as 4 time interval. So time interval number 1, time interval number 2, time interval number 3 and time interval number 4, like that. And this particular time interval number 1, what happens? We are connecting N1 to N2, N3, N2 to N4 for time interval number 1. Time interval number 2, N1 to N4, N2 to N3. It's called a crossover. Time interval number 3, N1 to N3, N1 to N4, upper broadcast. Time interval number 3, N2 to N3, N2 to N4. You can say it. So the 4 ways of connection can be possible there by using 2 cross 2 switching elements. Immediately what happens? The path is changing from time to time without altering your topology. Network cannot be changed. The wires are fixed. Okay, the wires cannot be changed, but only your path is changing from time to time can be possible there. And that type of networks will be called as dynamic network can be used, where the path is changing from time to time depending on the application environment, depending on the environment, depending on the scenario, depending on the environments, depending on the applications, depending of connecting the number of nodes, either N1 to N2 or N2 to N4 or N1 to N3, like that. So for that, I am using one way. Again, I am going for N1 to N4 and N2 to N3. I am using different way. And this can be done. Switching elements has to do all these options. Without varying this and this will be fixed. But the path is changing from one time to other time can be possible there. So your objective is now, don't change your wires, cannot be changed. Switching elements as changing their position from time to time dynamically can be possible there. And that type of mechanisms are called as dynamic network can be used. And these dynamic networks can be adopted where the number of nodes are too much and number of lines are too much is there. And then we can't be able to use a small number of nodes can be used, where switching elements cost will be extra compared to the previous, because here switching element cost is 0, but here switching element cost is very much important taking place. Automatically the cost will be increased. So for that reason, you choose the particular type of network depending on the applications, depending on the environment. You can go for static environment or you can go for dynamic environment can be choose. That depending on the applications, depending on the environment you choose for that. For that purpose only, we can able to adopt the type of network can be used. Either you can go for static environment or you can go for dynamic environment can be possible there. So for that reason, your objective now, you choose which is the better network depending on your environment can be possible there. So the best example for these dynamic networks are digital bus, and then MIN networks, that is, you can call it as crossbar switch networks. In the case of MIN networks containing of two components, omega networks and then baseline recursive networks. Omega networks, baseline recursive networks. They may ask you for 10 marks question. Design omega networks, design base recursive networks for connecting of n number of nodes like that. They may give you for 10 marks question like this. So you must be, next week I'm going for this particular omega networks and base networks can be used for connecting the n number of nodes between one point to other point can be possible there. Monday I'm taking the class. In that class, I'm going for designing the omega networks or designing of the baseline if the network can be used taking place. That can be either this or they may given for designing aspect, they may given for 10 marks will be given for that. Either it can give you omega networks or it can give you the basic network can be used. Depending on the problem, you write the answer like this. It's all about differentiate between static networks and dynamic networks. They may ask you for 5 marks. Explain different types of networks can be used in parallel processing environment. 2 types of network can be used. One is called a static networks. Second point is dynamic networks. So they may ask you compare static networks and dynamic networks. They may ask you for 5 marks or they may ask you for 6 marks like that. Depending on that, you write the answers. Next point, we are going for the static networks. Now we are going for different types of static networks can be used for connecting the number of nodes in the case of parallel processing environments. First is called as linear array. Second point, ring is there. Second point, third point, we can call as the cordial rings can be used here. So now, how linear array can be used for connecting the n number of nodes? You can figure here. ಇಟ್ಟಿದ್ದೇನಿದ್ದಾರೆ ಇಟ್ಟಿದ್ದೇನು ಹಾಂ ಹಾಂ ಸರ್ ಹೇಳ್ತೀನಿ ಹಾಂ ಹೇಳ್ತಿದ್ದೆ ಆಮೇಲೆ ಹೇಳಿ
My dear students, good morning. So, shall we have a project seminar on 23rd of this month online? Open mode. Please replay. Hello? Hello? My dear students, can we have a online seminar, project seminar phase 2 on 23rd of this month? Please unmute and answer. Huh?
No, sir.
Why you don't want online?
Sir, we want online, sir.
Then we'll have it on 23rd.
Sir, can we postpone it, sir?
When?
Sir,
23rd or 25th?
25th, sir.
25th is on Sunday.
No problem, sir.
No problem.
Sir, next week?
26th, Monday. Monday, Tuesday, classes is there. Instead of that, 28th of Wednesday we'll have.
Okay, sir.
Okay, sir.
28th Wednesday, online project seminar.
Okay, sir.
Okay, sir.
You have to give it to your guides.
Sir?
You have to give the presentation to concerned guides.
Yes, sir.
Okay, sir.
Okay? Understand?
Yes, sir.
Yes, sir.
Yes, sir.
28th of this month, project phase 2 seminar online.
Excuse me, sir.
Tell me.
Sir, on 28th, right, sir?
Yeah, 28th.
Okay, sir. Thank you.
Thank you. Thank you. Thank you. All the best. Be safe.
Thank you so much, sir.
Thank
Should
you,
be
sir.
there in the house only. Don't come. Don't roam anywhere.
Okay, sir. Thank you,
Thank
sir.
you. Thank you, sir.
Coronavirus 2.0 targeting the age group of 18 to 40. Be careful. Be safe. Keep safe. Be in the home only. Don't roam anywhere. Thank you.
Sir, how are you, sir?
Thank you, sir.
I also got corona positive, but I recovered. So I am telling my experience is a lot of trouble I have faced. A lot of things I have faced, but anyhow, somehow, because of the God grace, I came out of it. That's why I'm telling, be careful with the corona 2 virus. Be safe. Thank you.
So unmute your mic now. Unmute your mic.
Yes, sir.
ಒಂದು ಕ್ಲಾಸ್ ಅಲ್ವಾ ಅದು 20 ಕಡೆಗೆ ಬಂದಾಗ ಇಲ್ಲ ಕರಲಿಲ್ಲ ಒಂದಿಲ್ವಲ್ಲ ಆಯ್ತು ಹೇಳ್ತೀನಿ ಕಳಿಸ್ತೀನಿ. So now we are going for different types of content network can be adopted here. So they may ask you for again for 4 marks or 5 marks, explain linear array or ring type or cordial rings or barrel shifters. They may ask you for, I can say compare array and token ring like this, or they may ask you linear array and then cordial ring like that. They may ask you the question for 4 marks or 5 marks can be used. First point is that I'm going for linear array taking place. It's called a linear array means one type of static networks. It is a one type of static networks can be used. Where here I am connecting, you can see that the number of nodes I am using node number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16 number of nodes are there. You can see 16 number of nodes are there here. So I am using number of links I can able to use here. You can see L1, L2, L3, L4, L5, L6, L7, L8, L9, L10, L11, L12, L13, L14, L15 like this. So number of links I can able to use this L15 is there. So 16 number of nodes has to be connected required. So N is equal to 16 number of nodes are there. So links is equal to n minus 1 links. I can able to use that. ಹೌದು ಕೊಡ್ತಕ್ಕಂಥ ಬಿಡಿ ಕ್ಯಾಮ್ರಾ ಚೆನ್ನಾಗಿತ್ತು ಕ್ಯಾಮ್ರಾ ಚೆನ್ನಾಗಿ ಬರೋದು ತೆಗೆದಿ ನೋಡಿ ಕ್ಯಾಮ್ರಾ ತೆಗೆದಿ So number of links is equal to n minus 1 like this. So here the number of nodes are 16 like this, and here number of links is equal to n minus 1. So the 16 minus 1, that is equal to 15 number of nodes can be used. Here I can able to use 16 number of nodes here, L1, L2, L3, L4, L5, L6 and L7, L8, L9, L10, L11, L12, L13, L14 and L15 is there. So the number of links I can able to use is 15 can be used. Here the number of nodes I can able to use 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 13, 14, 15, 16 can be used. Where n is equal to number of 16 can be used, and then number of links can be adopted here is n minus 1 can be used. It is equal to 15 number of links can be adopted in the case of linear array can be used. Here, now what happens here, it is called as static environment. So automatically it is called as fixed network. We can call it as fixed network is there. And then topology is symmetrical topology can be used. Symmetrical topology can be used. Symmetrical topology can be adapted. So it can be called as symmetrical networks. That means symmetrical networks are those can be defined as where I can able to within a particular topology from a node will be same is there. I can able to see the particular topology from any side of the particular node. Topology will be same can be used, and that type of network will be called as symmetrical network can be used here. So that is, we can say linear array is the one type of symmetrical network can be adopted here, and then network diameter for this is equal to n minus 1. Network diameter is equal to, for this type of network is equal to n minus 1. So network diameter for this is n minus 1. So immediately what happens when the number of nodes are increases, that you must remember always, the number of nodes are increases. What happens? Network diameter is equal to, for this type of network is n minus 1. Network diameter and number of nodes are increases, automatically what happens? Diameter will be increases. The diameter will be automatically what happens? Cost will be increases like this. So immediately what happens? The complexity has to be increases like this. So for this particular type of network, we can able to use small number of nodes only can be used. Linear array can be used, large number of nodes can be used, n minus 1 value will be high, diameter will be high can be possible there. So when diameter will be high, automatically what happens? Network diameter will be high, number of nodes are large. The number of nodes are large, automatically complexity will be large, automatically the cost also increases. Diameter depending on what? Your wire cost, and wire cost will be increases. Immediately the wire cost will be high, and network diameter will be large, so n is large. So automatically what happens? For large number of nodes, we can't able to use that particular type of network cannot be used for large number of nodes, and this type of network can be used only for small number of nodes only can be adopted here. We can't able to use large number of nodes for this type of network can be adopted here. Only for where the applications, you can see, depending on the application, type of network can be used. So application is where n is equal to small, I can go for this type can be used. I can able to easily implement it for this array can be used where n is equal to very small number of nodes. N is equal to small, for that only we can able to choose that the particular network can be adopted here. When n is equal to too large is there, we can't able to use the network cannot be adopted here because the cost increases, complexity will be high, because network diameter depending on number of nodes can be taking place here. At the same time, what happens here, linear array can be adopted here. We can see in the case of a digital bus and linear array, one difference is there. You can say bus and linear array is there, where bus can be used called as time sharing bus. We can call it as time sharing bus, where I can able to use only one time the particular one sender and one receiver can be exchanged or communication takes place when a time can be allowed in the case of digital bus, in the case of bus. But here, what happens? Suppose the node number N2 and L2 can be used. What happens? Particular one time. Suppose you can say 10:30 here. At same 10:30, I can able to use L6. I can able to use L8. I can able to use L14. So 2 and 3, 6 and 7, 10 and 11, and 15 and 14 can be possible between 10:30 a.m. So what happens? You can say concurrent use of communication between the number of nodes can be possible at the only one time can be possible in the case of array can be used. But in the case of digital bus, we cannot possible there. So if you want to use in digital bus, what happens? Node number 2 to 3, 10:30 a.m. Node number 6 to 7, they can given as 10:45. Node number 10 to 11, they given as 11 a.m. Node number 15 to 14 will be given as 11:30, like this. That means it is the case of digital bus, where time is large. But in the case of here, array, what happens? All these things will be only one time can be possible. That is the one difference. Digital bus, this is the time interval. Array, we can do it, this particular number of nodes, only one time can be possible there. So the concurrent usage of communication takes place in the case of linear array can be possible. But in the case of digital bus, we cannot able to use. We can call it as time sharing can be used in the case of digital bus. But in this linear array, what happens? The communication will be, what happens between this point here, this point here, this point here, and this point to this can be possible there. So for that reason, linear array can be used. The concurrent communication between the number of nodes can be possible in the case of array can be used. But this mechanism cannot be possible in the case of bus environment can be used like this. So for that case, linear array can be widely used depending on the applications where n number of nodes is very small is there. And then this type of network can be used. Topology will be fixed. Symmetrical environment can be used. And the one more thing is that you can see that. So now next point is that no degree, what happens? You can see no degree in the figure. So this you can call as node number 1 and node number 16 will be called as boundary nodes. And then remaining 2 to 15 number of nodes will be called as inside nodes and intermediate nodes. You can call as inside nodes. So the boundary nodes we can call as, this is your boundary nodes, and this degree, link number 1 entering a particular degree, and this is going out to a particular environment. So degree should be always is equal to 1 in the case of boundary nodes. 1 and 16, degree is equal to only 1 taking place. Only 1 can be used. And the inside that, no degree is equal to 2. Inside number of nodes. You can say inside means 2. You can say here 2 and this, here and this and this, here and this and this, 2, 1 and 2. You can say degree. You can say in degree plus of degree is equal to degree of nodes. So these two links are there. Degree is equal to 2. In the inside number of nodes, degree is equal to 2. Then boundary nodes, degree is equal to only 1. Like that. That you must always identify that. This is boundary nodes, degree is equal to 1. Inside nodes, degree is equal to 2 can be possible there. That is, we can say the intermediate nodes, we can call degree is equal to 2. The boundary nodes, the degree is equal to 11 can be possible there. That is in the case of array type of static network can be used. A linear array, that is we can call it as linear array. They may ask you for 5 marks or 4 marks like that. Explain functions of linear array taking place. For that, you write the figures and explain the parameter like this. Write the figure for this and then explain the parameter for the linear array can be used like this. Next point is that second network can be used here called as ring type network can be used. So now the ring type network can be exactly same as your the ring structure. In your computer networks, you are going to use the ring topology can be used, or you can say bus topology and ring topology is there. Same case here also, it is called as ring topology can be adopted here. So here I am adding, suppose linear array, what happens here? Number of nodes and number of links is equal to n minus 1 in the case of array here. So this is, you can say 16 minus 1 is equal to 15 can be used. I am adding one extra link here, this point here, and that will be formed as ring type structure can be used. Okay, adding extra link for linear array, then that will form as ring type structure. It is formed as the ring type structure. So n minus 1 is there, but I am adding one more. This you can call as, you can see here. That will be formed as ring can be possible there. That is in the form of this type can be possible there. Adding extra link for the linear array, that will form as ring type structure can be used. Where network diameter for this environment is equal to n for unidirectional environment, unidirectional system. And then network diameter for this particular ring was equal to n by 2. That is for bidirectional system. So unidirectional means only n, bidirectional means n by 2 can be used. Diameter is equal to n for unidirectional, n by 2 for bidirectional can be adopted here. That is for n is for unidirectional, n by 2 for bidirectional can be used like this. That is for network diameter. And then degree of node, degree of particular ring type is equal to always 2. Here boundary nodes 1 is there, intermediate node is 2, but here degree will be common to everybody. So here like this, you can see this one link, the particular node number 1, link number 1, link number 2. So one link and one link. So 1 plus 1 is equal to 2 like this. 1 plus 1 is equal to 2 like this. Here also 1 plus 1, you can say L2 and L3. One link and one link for node number 2. Okay, L2 and L3 for node number 2 will be taking place. So immediately what happens? Yeah, degree. You can say in degree plus out degree is equal to degree of a particular node. Here in the case of ring type structure, degree of a node is equal to always should be 2. But here 2 and 1. But here ring type structure, degree of a node is equal to 2 only. That type of network will be called as ring type structure can be used. Where the communication mechanism for that, the protocol can be used for this is IEEE 802.5. That is, you can call it as token ring format can be used. Protocol can be used for this environment is IEEE 802.5 will be called as your token ring structure there. And then token ring structure means what here? One becomes the transmitter, the particular node which holds the token, and that becomes as master, and remaining all becomes as clients like this. Suppose node number N1, the particular node number 1 token is moving around the particular ring, and that particular node number 1 takes a particular token. Whenever the node number 1 takes a particular token, that is, you can call it as the time interval will be called as THT, token holding time. Token holding time, in that token holding time, node number N1 will be act like a master, and remaining all becomes as your receivers like this. So N1 send a particular message, and remaining all the number of nodes, this is the particular message only can be possible there. Okay. Node number N1 will be the master, remaining all the number of nodes are you can call as the client can be used. So they can receive the particular message from node number N1 to, again, all becomes receivers. They can say exactly same as your broadcasting. This is become master, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this. All the number of nodes are receiving your particular data from node number 1 at this token holding time. Suppose the token holding time will be given as from half an hour for node number N1. So after that, token will be released from node number N1. Then token given to node number N10 like this. So automatically N10 becomes as the master, and remaining becomes as your receive the particular data from N10 like this. That is, you can say in the case of the ring type structure can be allowed here, where we can able to make that particular structure is in the form of a ring type, or you can call it as ring topology taking place, and that environment will be called as ring type environment can be adopted like this. So this is called as the ring topology can be adopted here. Next point is that where you can call it as the cordial rings can be used. The cordial rings is a one type of ring topology or ring technology can be used. Exactly same as your ring, but the degree of a node increases 3, 4, 5, and 6. Then degree of a node above 2 will be called as cordial rings. So here you can see 1, 2, 3, 4, 5 like this. Here also 1, 2, 3, 4, 5, 6 like this. That is, you can say the cordial ring either 3 or 4. Cordial ring 3 means only all that becomes 3. Cordial ring 4, all that becomes as 4. Cordial ring 5, all that becomes as 5. Cordial ring 6. All the nodes having a degree is equal to 6 is equal to cordial ring 6. All the nodes having degree is equal to 3, cordial ring 3. All the nodes having degree is equal to 4, cordial ring 4 like this. All the node degree is equal to 5. It is called as cordial ring 5 like this. So what happens? The number of cordial rings, what happens? Network diameter is coming down. Network diameter will be, number of paths are too much, automatically what happens? The number of paths, too much paths are there, then immediately we can say among the path, we must take which is the shortest path can be obtained. Suppose you can say P1, P2, P3, P4 is there. Automatically what happens? Whenever P1 is there, P2 is there, P3 is there, P4. So P1 is, you can say, assuming that 2 meters, 2 number of hops, P2 is equal to 1 number of hops, 5 number of hops, and 6 number of lock kilometers. So automatically, the P2 will be the network diameter. Automatically, what happens? Number of hops is only 1 can be replaced. Immediately, what happens? Network diameter will be becoming less. In the number of degree, cordial ring, what happens? Where the degree will be large. At the same time, what happens? Network diameter will be coming less. Network diameter will be coming less. Automatically, what happens? The wire, can say wire requirement will be coming less. Immediately, what happens? The cost also of the particular system will be coming less, can be possible there. In the case of the cordial ring can be adopted here, where the number of links will be coming less, can be possible there. In the case of cordial ring can be used. Last type will be called as the barrel shifter. See here, in the case of barrel shifter, they may ask you for 5 marks. The barrel shifter is a one type of cordial ring. It is a one type of cordial rings. It is a one type of cordial ring. That means what? Degree of a node is more than 2 and above. Like you can say 3 or 4 or 5, like that is called as cordial rings, where the cordial rings can be defined as where degree of a node should be more than 2 will be called as your cordial rings. So the cordial ring, the barrel shifter is a one type of cordial ring. Why? Because degree of a node should be more than 2, either 3 or a 4 or a 5 or a 6 or 7, or it is called as a cordial ring can be used. That the cordial ring and barrel shifter both are different is there. In what way it is different? You can see that. So in the case of barrel shifter, I want to connect node number I and node number J. If difference between I and J is equal to 2 to the power of R. Difference between node number I and J, 2 to the power of R. Then only connect node I and node J. Difference between I and J to the power of R, then only we connect node I and node J. The question is there. So, where R is equal to 0, 1, 2, 3, 4, 5, 6, like that. Difference between node number J and I to the power of R, then known that is R is equal to 0, 1, 2, 3, 4, 5, 6, then only we can able to connect node I and J can be used. So what happens? Suppose node number 1, assume that I is equal to 1 and J is equal to 3. Node number 1, node number I is equal to node number 1, node number J is equal to 3. What happens? You can say 3 minus 1, that is equal to 2. 2 minus 3 minus 1 is equal to 2, like this. Or you can say, which is the highest one should be, always should be positive number. We must say I and J, which is the highest will be coming first and lowest will be coming last. So that is equal to 2. That means 2 to the power of 0 is equal to 1. 2 to the power of 1 is equal to 2. 2 to the power of 2 is equal to 4. 2 to the power of 3 is equal to 8, like this. So 2 to the power of 1 is equal to 2. Yes, it is possible. 2 to the power of 1. 2 to the power of 1 is equal to what? 2. So 3 minus 1 is equal to 2. Then what you can say? Then connect node number 3 and node number 1 is possible. Next point. Node number 3, node number 1 has to be possible because J minus I to the power of R is equal to 0, 0 to the power of 0 is equal to 1. So 1 is not there, to the power of 2, 2 is there, yes. We can able to connect this node number, particular J minus 1 is equal to I possible can be possible. To the power of 0, 1 is there, you can say 2 can be possible there, here. So you can see here what I can see, the figure what happens. So I will connect. At the same time, what I propose, I can say one more node is there. You see that J, suppose you can say I connect 2 minus 1, node 2 minus node number 1. What happens? To the power of 1, to the power of that is equal to 1, to the power of 0 is equal to 1. So possible. To the power of 0 is equal to 1. I get the value is equal to 1 can be possible. So I'm connecting 2 minus 1 is equal to 1 can be possible. 2 minus 1 is equal to 1 can be possible. To the power of 0 is equal to 1. 2 minus 1 is equal to 1 can be possible there. So 0 is possible, 1 is also possible. So suppose I can say I will connect 3 minus 1, 2, that's also possible there. At the same time, I'm connecting 5 minus 1, what happens? 4. Node number 5 to connect node number 1. 5 minus 1 is equal to what? To the power of 2 is equal to 4 can be possible. Is also possible there. So the barrel shifter is a one type of cardinal ring where we can able to count the number of nodes if the difference between J and I is equal to the power of R, where R is equal to 0, 1, 2, 3, 4, 5 like this. To the power of 0 is equal to 1. So difference between node number 3 and 2 is 1. So automatically I can able to connect 3 and 1 can be possible. Or 3, 1 is equal to 2. 2 to the power of 1 is possible, no problem. Either 2 and 1, 1 is there, no problem. 3 and 2, what happens? 3 minus 2 is equal to 1, no problem. 4 minus 3 is equal to 1, no problem. 5 minus 4 is equal to 1, no problem, like that. So 1, 2, 4 like this. So in that particular scenario, you can see the particular figure here. See the figure here. What happens? I'm joining 2 minus 1. What happens? No problem. 2 minus 1 is there here. 2 is there here. It is 2. It is 1. So I join this. Again, 3 and 2, 1. No problem. I can able to join this. 4 minus 3, 1. No problem. 5 minus 4. No problem. I can able to join this. 6 minus 5, 1. No problem. 7 minus 6, 1. No problem. 8 minus 7, 1. No problem. 9 minus 8, 1. No problem. 10 minus 9, 1. No problem. 11 minus 10, 1. No problem. So don't join 1 and 9. Be careful. Don't join 11 minus 1 is equal to 10. So what happens? There is no 10 here. To the power of 4 is equal to 16. Not possible. Be careful. Don't join 11 minus 1 is equal to 10. But here 1 is there, 2 is there, 4 is there, 8 is there, 16 is there. Be careful. Don't join the particular 11 cannot possible. At the same time, you would join 4 minus 1, it is equal to 3. So what happens? 2 is there, 4 is there. So don't join 4 and 1 cannot be joined. Be careful. So difference should be either 0 or to the power of 0, to the power of 1, to the power of 2, to the power of 3, to the power of 4, to the power of 5, to the power of 6 can be possible then. Otherwise, don't join the 11 and 1 cannot be joined because why? 11 minus 1 is equal to 10 like this. So 10 cannot be there in this ratio. To the power of 0, to the power of 3 is equal to 8, to the power of 4 is equal to 16. So 10 cannot be possible there. So automatically, if it is not possible there, don't join the particular number of rows cannot be joined. So for that case, you can say that to the power of 11 minus 1 is equal to 10. Here 4 minus 1 is equal to 3. Not possible there. So here for that, I am not joining here. You can say 4 and 1, I am not joining here. And then 10, 11 and 10, I can join here. And suppose I am joining 3 and 1 can be joined. Node number 3, node number 1 is there. Node number 3 is there. Node number 1 can be joined because what happens? 3 minus 1 can be 2 can be joined here. 3 minus 2 can be 2 can be joined here. Again, what happens? 5 minus 3 can be 2 can be obtained. 5 minus 3, what happens? 2, that is equal to the power 4 is equal to 2. Automatically, what happens? 2 is finished. 5 minus 1 is equal to 2 can be possible there, like that. 2 to the power of 1 minus 1, 1 possible. 3 minus 1 is equal to 2 possible. 5 minus 1 is equal to 4 can be possible. So it automatically I join this 5 and 1. You can see this is your node number 1. This one I can able to link this as node number 5. This 5 minus 1 is equal to 4 can be possible. 5 minus 1 is equal to 4 can be possible. That is, you can call it as the barrel shifter. They may ask you for 4 marks. Okay. Differentiate between barrel shifter and a cardial ring. They may ask you for 4 marks. Or they may ask you, explain why the barrel shifter is different from cardial rings. With an example, they may ask you, explain how barrel shifter is different from the cardial ring with an example. So, barrel shifter is a one type of cardial ring, but only one thing difference is that node J and I will be connected only if J minus difference between J and difference, I'm saying difference between J and I is equal to the power of R, where R is equal to 0, 1, 2, 3 like this, where R is equal to 0, 1, 2, 3 like this. That is called as, so that is the main difference. So if you draw a particular figure for this and put the numbers 2, 1, 3, 2, again 2 to 1 is equal to minus, again 5 minus 1 can be possible. Either you can go for 7 minus 1, not possible. Either you can go for 6 minus 2 can be possible. Yes, 6 minus 2 can be possible there. 6 minus 2 can be possible. 6 minus 2 is equal to what? 4. 4 is equal to what? Yes, can be possible. To the power of 4 can be, to the power of 2 is equal to 4 can be possible there. To the power of 4, 2 is equal to 4 can be possible there. Here I am using 1, 2, 3, 4, 5, 6. Here 1, 2, 4, you can say 1, 2, then 4, then you can say here, next point is there 8 can be possible. Other you can say, I want to join 1 and 9 can be possible. You can see, I will join 1 and 9 can be possible. So 9 minus 1, what happens? It is equal to 8. So 2 to the power of 3 is equal to 8. So I will join node number 9, node number 1. That is 9 minus 1 is equal to what? 8. So 2 to the power of 3 is equal to 8 can be possible. That is also possible. 9 minus 1 is equal to 8 also can be possible there. That is the main difference between cardial ring and the barrel shifter there. They may ask you for 5 marks. They may ask you for 4 marks. Next, we'll move on to tree type structure, then star type structure. Third type will be called as the fat tree. This is the figure for static networks. Again, static networks only. Other types can be used. You can say 8 or 9 types, 10 types are there. Let me ask you any one types for explaining for particular tree. Here's the major one. We are going to explain that. The first point is that again, fifth point of this type of network will be called as 1, 2, 3, 4, 5. Then you can go for sixth will be called as tree type structure. Then you can go for star type structure. Then you can go for the fat tree environment like this. So now we can go for a tree type structure where the number of nodes are connected in the form of binary tree. The number of nodes, you can say node number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like this one. And then where n is equal to number of nodes, where n is equal to number of nodes, where k is equal to number of levels of a tree, where k is equal to number of levels of a tree. That is, n is equal to number of nodes, k is equal to number of levels of a tree. If suppose I know the value of k, then immediately the number of nodes connected in the particular tree is equal to 2 to the power of k minus 1. I know the value of tree levels. That particular tree, how many levels are there? Depending on the levels, I can able to link number of nodes can be linked. I can able to link if the number of k value will be known automatically. I can able to measure what is the number of levels, level 1, level 2, level 3, level 4 like this. So immediately here 2 to the power of k minus 1, where k is equal to levels of a tree, where k is equal to level of a tree. Suppose here in this figure, level is equal to k is equal to 4. We can say first level, second level, third level, fourth level. So 2 to the power of 4 minus 1, that is equal to 16, that is equal to 15 k. Here what happens, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes. 2 to the power of k minus 1 will be the number of nodes. This k level of tree has to connect this number of nodes. 2 to the power of k. Know the value of k. Automatically, we must know how many nodes are connected for this particular tree can be possible. 2 to the power of k minus 1 can be possible there. 2 to the power of k minus 1, 2 to the power of 4 minus 1 is equal to 16 minus 1 is equal to 15 can be possible there. Here you can see 15 can be possible there. Network diameter for this is equal to 2 into k minus 1. Network diameter for your tree type structure is equal to 2 into k minus 1, where k is equal to number of levels of a tree can be possible there. So you choose the type of applications if the number of nodes are connected in the form of hierarchical structure, connected in the form of the tree type structure. Then we go for tree type can be used. Depending on your applications or depending on the environment, we can able to choose the tree type can be adopted, can be used. Here we can see this L1, L2, L3, L4 like this. Suppose I am using L1, L2, L3, L4, L5 will be only 10 kbps. Assume that the bandwidth or we can able to supply only, can able to transport only 10 kb can be used. All that becomes 10 kb. L1, L2, L3, L4 like this. What happens? You can see is the main drawback. Observe here. Suppose node number 8 will transmit 5 kbps. Here 5 kbps, no problem. It is 10 kbps is there. 5, no problem. Here 5, no problem. So the maximum level. Come to here 10 coming at this point. At the same time, here also 10 coming at this point. What happens? So L3 here you can say, assume that L7 like this. So L7, 10, L3 will be 10, L7 will be 10 can be possible. No problem. But here what happens? 20 can be there. So here my capacity is 10 kb. I am sending as 20 kb. Main drawback. This is called as the bottleneck problem. Your capacity, link capacity, the topmost layer going top will be increases too high. Automatically what happens? Link capacity is equal to only 10 kb is there. Link capacity is there. But we are going on increasing this value to higher value. Automatically what happens? 10 plus 10 is equal to 20. What is your maximum level? 10 kbps only. Automatically this L4 link will transmit only 10 kb, but I am having load is equal to 20 kb can be possible there. My load is 20 kb, but you are sending, your capacity is only 10 kb. So automatically what happens? Data will be lost. Your capacity exceeds your capacity. Maximum level will be exceeds here. So automatically what happens? That is the bottleneck problem of the particular load on the particular link goes on at the higher level will be increases. And this is the main problem in the case of tree type structure. And this problem is overcome in the case of fat tree. That's all. Only one difference is there. This is the main drawback is there, and that drawback is overcome in the case of fat tree environment can be possible there. Next point is that if you're going for this is called as your star type structure, where we can this particular star type structure will be called as the client server communication, client server environment, widely used for client server environment. And this can say supervisory node environment. That means supervisory node means this is you can call it as your server. And all that becomes as C1, C2, C3, C4, and C4, all these things. Network diameter will be maximum is only 2. This is 1 and 1. This is this point here, 1, this point here is 1. It's uniform distance. Okay. This point to this point here will be 1. Here also 1, 1, 1. All our ones are there. Distance will be uniform is there. All our becomes as 1s. So automatically what happens? Network diameter is equal to 1 plus 1 is equal to 2. Maximum is only 2 can be used. And it is widely used for the number of server and the client. Here I will place the particular server, all that becomes as your clients. And all the clients are placed at uniform distances. That you must remember always. All the clients can able to place at uniform distance only. Why? Because when distance will be vary, automatically what happens? Time for giving a responses is vary. Distance is vary. Time for sending a responses is vary. Distance is constant. Automatically what happens? All the clients with the particular data at the same time can be possible there. Because of this context, I can able to use that star type technology can be used where distance is uniform to all the nodes from the center node. Distance is uniform to all the nodes from the center node. This is center node. Distance to all the nodes is uniform from the center node, and that is called as star type topology. So for that case where the star type topology can be adopted only for if you provide the server and connect the number of clients. And all these clients are connected at uniform distances. Why? Because only why here the data movement to all the clients will be uniform can be possible there. So your objective is now only the data will be received from all the clients from your server should be maintained at uniform level can be possible. For that cases, we prefer the star type topology can be adopted, can be possible there. That is, we can say the star type topology can be used like this. Next point is that if you're going for the fat tree environment, you can say it is also one example for tree type structure. This is one example for it's also tree type structure. Here also you can see here is 2 nodes, 1 is there. You can see these 2 nodes and 1 is there. So you can say here you can say 10 kbps. Here you can say 20. Here you can say what happens 20 here. Here also becomes as 20 plus, and you can say I will make that as 50. I will make it 100. I will make it as 500. So you can see here only one link is there. Here 2 links are there. 2 links. Here you can see 3 links are there. Here you can see 4. 1, 2, 3, 4 links. Here you can see 1, 2, 3, 4, 5. Here next you can see if you're going for higher version 1, 2, 3, 4, 5, 6. You can see that. This point. Then go for topper. That becomes whenever the nodes are going from topper, yes, what happens? Your media becomes thicker. This is 2, 3, 4, 5, 6. the media becomes thicker. Because thicker means what? Large number of media can be used. Automatically, why do you prefer this here? Large number of the media can be used. This is the problem existing there. Here, what happens? 20 kb is there. 10 kb will be lost. What happens here? I am using 10 plus 10, 20 is there. No problem. Here I can go for 50. 20 plus 20, 40. I buy for 50 is there. No problem. Here 50 plus 50, 100. No problem. You can say 100 plus 100, 200, I can 500 is there. No problem. Automatically what happens? Where your load capacity will be goes on increases from bottom to top. Where the number of links are added from bottom to top. Here I am using only one link, but here I am using 2 number of links. Next level, 3 number of links. Next level, I am going for 4 number of links can be used. And the next level, I am going for 5 number of links can be used. And then I can go for 6 number of links can be used like this. So your objective is now, what is the bottleneck problem existing in the theorem of tree type structure? Bottleneck problem of tree type environment is overcome. That means what? This is my bottleneck problem is 20 is there, but I am giving only 10 is there. Problem is existing here. So, and that problem, bottleneck problem is overcome. I can able to overcome your bottleneck problem. Why? Because number of links are added from bottom to top. Here 20, 3, 4, 5, then 6 can be given. That becomes as a bigger version. So small here, again bigger, again bigger, again bigger like that. Automatically what happens? The number of medias are increases. What happens? Here I am using only one link will carry 10 kb, 10 kbps. If you add 5 number of links, 50 kbps. Automatically what happens? Earlier I am using only 10 kbps. Here I am using 50 kbps for next level. 100 kbps, 500 kbps, like that. So immediately what happens? Number of levels goes on increases. At the same time, your load capacity also will be increases. Load capacity will be high. Automatically what happens? The maximum load capacity will be higher. Automatically data loss will be reduces from bottom to top. Data loss will be less. Automatically what happens? Performance will be high. Can be positive. At the same time, network performance will be, again, whatever the data sending from this point to your topmost node will be available safely without losing of any single data is there. Then only that performance will be called as, the performance will be high, can be obtained like this one. Because if the data will be lost, suppose here what happens? Suppose I am sending as 20 kbps here, or 20 kbps is there, but I am receiving as 10 kb like this. 10 kb of data will be lost. Automatically what happens? Performance will be decreases. It cannot be allowed. Your objective is that the communicating the data from one point to other point. If the communication is lapses taking place, automatically what happens? The problem will be existing there. That cannot be allowed. Automatically the performance will be decreases like this. So that is the main drawback existing there. So the performance cannot be decreases like this. So for that reason, what is the problem existing in the case of tree type structure, and that problem can be overcome in the case of fat tree can be used like this. It's called as different types of that can be used. One more is called as systolic array is there. One more. Okay, Monday will take the particular systolic array chapter, because they may ask you again 5 marks for systolic array like that. Systolic array again they given as one type carpenter can be used, but will be given as 5 marks. They will ask especially for systolic arrays like that, short for systolic arrays like that. Monday I'll take up the systolic arrays. Immediately I will move on to dynamic networks. So dynamic networks again, digital bus is there, MIN is there, and then transistor is there. That will be covering against unit number 3 portion off. Immediately I am going to over to memory hierarchy. some part of the memory hierarchy in the case of unit number 3. It's above the memory like this. So in this class, discussing about only what are the different performance parameters that may affect network performance. Immediately we will move on to types of network can be used. After the type of network, static and dynamic is there. Then we will move on to static type of networks. Out of static type of networks, we are using 10 types can be used. Out of these 10 types, I'm explaining 9 types or 8 types already over. Okay. Next class, we can able to explain that 10th type. We can see systolic arrays, iliac mesh, and then torus is there. And then mesh type, iliac mesh. Then you can go for torus type of network can be used. Next, we can move on to what is the defining of hotspot. What is the meaning of hotspot? Then what is the network throughput is there. Network throughput, or we can say hotspot can be defined in what way? Like this, that will be covering on next Monday class. And then immediately switch over to dynamic environment and the Monday class. Till today, I can able to come back static networks only, a little bit only. Maximum will be covered. Only one part is remaining. That will be covering on next Monday. And again, immediately dynamic networks can be adopted in the case of Monday class. Dynamic network can be used in the case of Monday class. Can able to cover this. Okay. Till that, we can able to stop at this cover only for this type of networks. They may ask you for 4 marks or 5 marks. Or they may ask you for comparing cardinal ring linear array only for 5 marks, tree and fat tree like this, or which particular connection can be used for connecting of supervisory nodes, or you can say this application connecting of client server environment, which topology can be used. That is called as star type can be used like this. And why we can able to use that? Because of this will maintain uniform distance has to be maintained to all the number of nodes. For that only, we are connecting the star topology can be widely adapted like this. They may ask you for 4 marks or 5 marks like that.